Hey, this is John from KCM Solutions, and now we're going to take a look at the business application drill down section for Turbonomic. When examining this business application within the context of Turbonomic, the supply chain is restricted to displaying only the entities that are pertinent to this particular application. This business application comprises of 3 business transactions, 2 services, and 3 application components that are distributed across 3 VMs or virtual machines. These virtual machines reside on a singular host, which is linked to 2 storage devices. The entities are classified by color, with red indicating performance risk, yellow indicating efficiency opportunities, and green indicating entities are in their respective desired states. By focusing on the specific application, potential congestion risks or wastage of resources can be quickly identified. Turbonomic provides metrics for response times and transactions per second, along with their repetitive level service objectives, which can be established within the policy sections. In Turbonomic, a business application is largely defined as a logical grouping of business transactions, services, and application components of the application model that collaborate to form a complete application as seen by the end users. If you scope to the business transaction, it represents a capability within your business application that fulfills a response to a user initiated request. Its performance directly impacts this user's experience. Scoping to the service entity, it is made up of 1 or more application components that perform a defined measurable function as part of an internal or user initiated request. Its performance is key to understanding application performance, but will only indirectly impact the user's experience. Finally, if you scope to the application component, it is a software component, application code, or unit of processing within a service that consumes resources to enable it to perform its function for the business application. Turbonomic can recommend actions to adjust the amount of resources available within these application components. Next, Turbonomic does not recommend actions for business application, transaction, services. However, it does recommend actions for the underlying application components and infrastructure entities, thus providing visibility into the risks that have a direct impact on the business application's performance. You can see here in the pending action widgets the type of actions generated. These are placement actions to move a virtual machine to the most desirable host or storage form from one tier to the next. Delete actions to remove storage volumes that have been orphaned over time. Scaling actions to resize a virtual machine, container, or database. Stop or suspend actions to turn off idle resources and to avoid unnecessary charges. And finally, start or buy actions to turn new VMs, provision a new host, or buy reserved instances within the cloud. Within this example, there are 789 actions that can be taken to move this hybrid environment into the optimal, or what we call desired state. You can see there are actions to scale up the virtual CPU or virtual memory of virtual machines, provision actions to add a host of clusters where resources are low, and move actions to move a virtual machine from one host to the other. Because there are hundreds and sometimes thousands of actions within an environment, Turbonomic allows you to apply filters to the list of actions to help you quickly sort the list. Clicking filter option and opening the dropdown, you can filter the actions by action type, action mode, action category, action prerequisite, or entity type. You're also able to switch to a new view using the toggle switch in the top right corner. The modernized view helps browsing through different types of actions with the navigation menu on the left. You may ask, how does one know that these are the correct actions to take? For each action, Turbonomic shows you not only the current state of the environment, but the positive impact on the environment once the action is taken. Let's expand to a couple actions to show you what I mean. We'll start off with a move action. Upon reviewing the details of this move action in Turbonomic, it appears that the virtual machine is being relocated to a new host due to memory congestion within the current host. Each metric displayed in Turbonomic indicates 2 values, the current state on the left and the projected state after the action is taken on the right. Moving on, let us focus towards VM scaling within Turbonomic. Turbonomic is a platform that helps with virtual machine scaling in the cloud. It uses percentile calculations to help get a better understanding of virtual CPU, memory utilization, and then recommends scaling actions to improve the overall usage and reduce costs. When you look at the details of a scaling action for a virtual machine, you'll see charts that show the virtual CPU and or memory utilization percentiles for a certain time period, as well as projected percentiles after each action is taken. An important point to highlight here is that these actions are not simply recommendations on what a user should do. These are actions that can be taken within the Turbonomic platform. For example, if the action mode is set to manual, I can click on this checkbox, scroll up, click Apply Selected, and this virtual machine will move to the new host. Or in this case of the resizing action, the VM will be resized. Taking this even further, you can create automation policies so that Turbonomic takes a preventative approach to automatically take these actions before issues occur. This keeps the environment within the desired state without human intervention and minimizes the amount of time that IT teams must spend debugging application resourcing issues after they occur, and it assures that the applications get each of the resources that they need exactly at the point of time in which they need them. In other words, Turbonomic assures that the demand of the application is met in real time by the supply of available IT resources. Finally, these actions can be scheduled to execute during a maintenance window and even get approvals via change requests through Turbonomic's integration with the platform ServiceNow. Now, let's explore how SRE can set up various automation policies. Now, let's create a single automation policy for virtual machine placement and resize. In addition, let's assume that you want placement actions to execute anytime the action is generated and that you want to resize up and down actions for vCPU and vMem to occur nightly. First, let's give the policy a name. Example, VM placement resize. Next, let's scope to a group of VMs, and in this case, let's automate them within a singular cluster. Followed by, under Action Automation and Orchestration, click the Add Action button. You can choose the action type to move/compute computer scale to automate placement, action generation to generate actions, and action acceptance to automatic, followed by clicking Submit. To add resize automation, click Add Action again. You can now choose the 4 action types: vCPU, resize up, vMem, resize up, vCPU, resize down, and vMem, resize down to automate the VM resizes. Set the action generation to generate actions and action acceptance to automatic. For resizes, we said that you wanted to do them on a schedule between midnight and 5 a.m., which can be done with the action execution schedule. Now, let's create that schedule. Save the schedule, choose the option nightly, and then click Save, followed by clicking Submit to save the automation. Then, click Save and Apply to apply the furthering policy. You can see that there is a lot of flexibility in setting the policies and that you have full control if these actions are taken manually or fully automatically.